This video is about Euler's method to estimate the solution of differential equations. In this video, I will focus on how to use a graphing calculator to estimate the solution of differential equation by Euler's method. We already know this is the formula for Euler's method. When you put into graphing calculator, x sub n equals u sub n, y sub n equals v sub n, and x sub n minus 1 equals u sub n minus 1. Y sub n minus 1 equals v sub n minus 1. It's just in the graphing calculator, u sub n minus 1, you have to use this way to show. So when you use Euler's method to estimate the solution of differential equations, you have to put in this format. Minimum for n always be 0. U sub n equals u sub n minus 1 plus this h. This h will be the step size, sometimes 0.1, sometimes 0.05. It depends on the certain problem. Then for the u sub n minimum value, this will be the initial value. So I write down the x0 and y0. This is the initial conditions given by the problem. Here's the way how to write down the v sub n. In other words, y sub n. Y sub n equals y sub n minus 1, and I will change it into v sub n minus 1 plus h. Both is h. For over here, and you will change into u sub n minus 1 and v sub n minus 1 instead of for x n minus 1, y n minus 1. Let's go to the example 1. Consider the differential equation dy by dx equals negative xy, where y equals 1 when x equals 1. Use Euler's method with a step size 0.1 to find an approximate value of y when x equals 1.5. First of all, we need to go to mode. Then you need to highlight this sequence. Then go to y equals. For this n minimum, always 0. And u sub n minimum value, it will be the initial value. According to the given information, initial value will be x equals to 1 and y equals to 1. So here is 1. Then go to v sub n minimum will be 1. Then for the u sub n equals, u will be this one. Second 7, that will be u, parentheses, n minus 1. Then you need to plus h will be step size 0.1. For v sub n, basically that is y sub n. You will get v sub n minus 1. So second v, parentheses, n minus 1. Then plus 0.1 will be the h. Here's the 1. You need to substitute u sub n minus 1 and v sub n minus 1 into this differential equation. So you have a parenthesis negative second 7, that's u, parenthesis n minus 1, then times v, parenthesis n minus 1. Be careful with parentheses. You need to put another parenthesis because the very beginning, when you put in parenthesis negative u sub n minus 1. After you put in this, you will go to second graph. They will show you this table. Then we are looking for 1.5. X equals 1.5. It's here. So your answer will be 0.527 for y. This is an approximate value. It's not accurate value. For the accurate value, you have to solve this separable differential equation to figure that out. Now let's go to the second question. Consider the differential equation dy by dx equals square root x over 4y, where y equals 3 when x equals 4. Use Euler's method with a step size 0.05 to find an approximate value of y when x equals 4.5. Now let's go back to this y equals. N minimum still 0. For the u sub n, you need to change this h. So h will be 0.05. And initial condition is changed. X equals 4. Then the y equals 3. For v sub n equals, we've got to use this formula. So we have a second v parenthesis n minus 1 plus 0.05, that's the step size, times. We got to use this formula. So we do second x squared, that's a square root. Go to alpha y equals, enter. This x you got to change into u sub n minus 1. So we have a second 7, that's u parenthesis n minus 1. Then over 4 times. Y you need to change into v sub n minus 1. So second 8, that's v parenthesis n minus 1. Then you can go to second graph or check the table. When x equals 4.5, the approximate value of y will be 3.29.